Hello, dear student. Welcome to you in my YouTube channel, Tomar Study Circle. In this video, we are going to discuss a problem of moment of force. The problem is seen on your screen. In this problem, a painter set up a uniform plank so he can paint a wall. The plank is placed horizontally on these two walls. The At this point, the pole exerts a force A on the plank. At this point, the pole exerts a force B on the plank. These distances are 0.5 meter and 0.5 meter, and the length of plank is 3 meter. It means the distance between these 2 points is 2 meter. The weight of the plank, which acts at the center of the plank, is given as 500 Newton. Hence, the distance between B and center will be equal to 1 meter. In the question, it is asked that use the principle of moment to show that the upward force is 250 Newton. Since the plank is in equilibrium, hence the net force as well as net torque acting on the plank will be 0. On using the principle of moment or torque, we can write toe net acting on plank will be equal to 0. If we see clearly, this force have a tendency to rotate plank along this line, along this direction. This is known as anti-clockwise direction, and the force A have tendency to rotate the plank along clockwise direction. If we take the moment about this point, then the clockwise moment or clockwise torque will be equal to the anti-clockwise torque. Or you can write toe clockwise will be equal to anti-clockwise. Right? We know that toe will be equal to force multiplied by perpendicular distance of the line of action of force from the point about which we will take the moment of the force. Okay. The perpendicular distance between A and B is 2 meter. Let the force acting on A is Fa, then toe clockwise will be equal to Fa multiplied by perpendicular distance, that is 2 meter. Or we can write that will be equal to twice of Fa Newton meter. This is basically toe clockwise. If we take toe anti-clockwise, then we can write toe anti-clockwise will be equal to, this force is 500 Newton, and the distance, perpendicular distance of this force or line of action of this force from B is 1 meter. Hence we can write toe anti-clockwise will be equal to 500 multiplied by 1, that is equal to 500 Newton meter. On putting the value of toe anti-clockwise and toe clockwise in this equation, first we can write 500 will be equal to twice Fa, or implies that the force acting at the point A, Fa, will be equal to 250 Newton. This answer match with the answer given in the question. The second question is state the value of force acting on B. Okay. On applying the translational equilibrium, the vertical forces will be equal to the horizontal forces. There are two vertical forces, vertically upward direction, force A and force B, and one vertically downward force, that is equal to 500 Newton. On applying translational equilibrium, the net vertically upward force net vertically upward force will be equal to net vertically downward force. Or we can write the vertically upward force is Fa plus Fb, and the vertically downward force is 500 Newton. On putting the value of Fa from equation first, we can write 250 plus Fb will be equal to 500 Newton, and implies that Fb will also equal to this answer is same as that of the first, that is equal to Fa. For more of such type of video, please like and subscribe my channel. Thank you for watching.